Here we want to learn about different kind of sorting and searching through arrays like BOGO sort, bubble, selection, insertion sort, and other sorting algorithms. And also we learn about searching through a one-dimensional array. Ordering elements in a data structure is sorting. So in these videos, we're going to work with one-dimensional arrays. So we can sort them in an ascending order or in a descending order. When we sort the elements of an array in an ascending order, or we call it non-decreasing order. So it's in an increasing order. Like in this example, we have an array, a one-dimensional array with these values 2, 3, 9, 12, 12, 17. So as you see, it's in an ascending order. We sort it in an increasing order. But if we want to sort this array in a descending order or in a decreasing order, that would be 17, 12, 12, 9, 3, 2. So as you see, it works even with duplicate values, because here, as you see, 12 is a duplicate value. So in this videos, we are going to work with one-dimensional arrays, and we are going to sort them mostly in ascending order. And if you want to, if you learn that, you can also sort them in a descending order. One of the sorting algorithm is BOGO or bogus. That is, while an array isn't sorted, you randomly permute it or you randomly shuffle the values, and you do it over and over again until the array is actually sorted. So the least efficient way, the least efficient algorithm in sorting was bubble sort. So someone came up with this idea that, hey, we can have the worst algorithm, and they wrote the BOGO sort to show that it could be even worse.
So in our unit about sorting, I think it's always fun to start with the worst possible sort technique, which is called BOGO sort. So here I've got my array of 6 values. And the way BOGO sort works is kind of like the way the game of 52 card pickup works, which is you throw all the cards up in the air and you pick them all up again. So we're going to do that with our array until it's sorted. So I click it and they're randomly moved around and still not in order. So I try it again. Nope, still not in order. Nope, no, it's closer. Nope, further. Not really close. You know, the zero's in the right spot. That's progress, right? Oh, now it moved. Oh, 0 and 1. I'm getting close. Now it's further away. And if you're frustrated by this technique, it's because it's really dumb. You should never actually do BOGO sort. In fact, the code you'd have to write to get BOGO sort to work is pretty complicated. So you don't want to even try this technique. It's really to kind of describe how bad it is. If you really wanted to try to sort an array with the computer using BOGO sort, it could potentially take sorting an array of 8 elements up to 10 minutes to half an hour just by randomly sorting it and then seeing if it gets lucky. So this is not a very good sorting algorithm. It's not predictable. Sometimes it'll get done right away if you get really lucky, but most of the time it takes a really long time. So my recommendation is do not use this technique, but make fun of it at any chance you get.
Now we want to learn about bubble sort algorithm. This algorithm is much better than BOGO algorithm. In bubble sort, we start off with an array of values. Here is an example.
Here's what we'll do. We're going to compare consecutive items.
If they're out of place, we'll swap them. The highest number will bubble its way to the right with each iteration. A sorted partition will form at the end of the array. It's pretty simple, so I'll be quiet and let you watch. Done with the first iteration. 9 is now in the correct spot. Let's continue. You get the picture. I'll see you at the end of the algorithm. We're done.
So here is the algorithm for bubble sort. It compares each element except the last one with its neighbor to the right. If they are out of order, swap them. Compare each element except the last two with its neighbor to the right. If they are out of order, swap them. Compare each element except the last three with its neighbor to the right. Continue as above until you have no unsorted elements on the left. Here is another example. We have an array of integer with these values 7, 2, 8, 5, and 4. And we want to sort them by bubble sort. So first what it does, it compares the first value with its neighbor. So 2 and 7 would be compared because 2 is less than 7. So it swaps these two values. Then it compares 7 with the next value, 8. Because 7 is less than 8, so it doesn't swap them. Then 8 with 5, so because 5 is less than 8, it swaps 8 and 5. And then 8 with 4, so it swaps 8 and 4. So at the first iteration, as you see, the biggest number goes to the last, and it places in its own zone. So for the next iteration, again, it starts comparing the first two with 7, it doesn't swap them. Then 7 with 5, it swaps 5 with 7. And then 7 with 4, and it swaps 4 and 7. So as you see, the biggest number again goes to the last. Then the next iteration, it starts over and it compares 2 with 5, and because 2 is less than 5, it doesn't swap them. Then 5 with 4, so it swaps 4 and 5. As you see, the biggest number goes to the last, goes to its own place. So that was the third iteration. And then for the next one, it compares 2 and 4, and it doesn't swap them. So as you see, it compared all the values together until it gets sorted.
So the basic idea behind bubble sort is this. we generally want to move higher valued elements generally to the right and lower valued elements generally to the left, as we would expect. We want the lower things to be at the beginning and the higher things to be at the end. How do we do this? Well, in pseudocode, we could say, let's set a swap counter to a non-zero value. We'll see why we do that in a second. And then we repeat the following process until the swap counter is 0, or until we make no swaps at all. Reset the swap counter to 0 if it's not already 0. Then, look at every adjacent pair of elements. If those two elements are not in order, swap them and add 1 to the swap counter. If you're thinking about this before we visualize it, notice that this will move lower valued elements to the left and higher valued elements to the right, effectively doing what we want to do, which is move those groups of elements in that way. Let's visualize how this might look using our array that we use to test out these algorithms. We have an unsorted array here again, indicated by all of the elements being in red, and I set my swap counter to a non-zero value. I arbitrarily chose -1, it's not 0. We want to repeat this process until the swap counter is 0. This is why I set my swap counter to some non-zero value, because otherwise the swap counter would be 0. We wouldn't even begin the process of the algorithm. So again, the steps are reset the swap counter to 0, then look at every adjacent pair, and if they're out of order, swap them and add 1 to the swap counter. So let's begin this process. So the first thing we do is we set the swap counter to 0, and then we start looking at each adjacent pair. So we first start looking at 5 and 2. We see that they are out of order, and so we swap them, and we add 1 to the swap counter. So now our swap counter is 1, and 2 and 5 have been switched. Now we repeat the process again. We look at the next adjacent pair, 5 and 1. They're also out of order, so we swap them and add 1 to the swap counter. Then we look at 5 and 3. They are out of order, so we swap them, and we add 1 to the swap counter. Then we look at 5 and 6. They're in order, so we don't actually need to swap anything this time. Then we look at 6 and 4. They are also out of order, so we swap them, and we add 1 to the swap counter. Now, notice what's happened. We've moved 6 all the way to the end. So in selection sort, if you've seen that video, what we did was we ended up moving the smallest elements and building the sorted array essentially from left to right, smallest to largest. In the case of bubble sort, if we're following this particular algorithm, we're actually going to be building the sorted array from right to left, largest to smallest. We have effectively bubbled 6, the largest value, all the way to the end. And so we can now declare that that is sorted, and in future iterations going through the array again, we don't have to consider 6 anymore. We only have to consider the unsorted elements when we're looking at adjacent pairs. So we have finished one pass through bubble sort, so now we go back to the question, repeat until the swap counter is 0. Well, the swap counter is 4, so we're going to keep repeating this process again. We're going to reset the swap counter to 0 and look at each adjacent pair. So we start with 2 and 1, they're out of order, so we swap them, and we add 1 to the swap counter. 2 and 3, they're in order, we don't need to do anything. 3 and 5 are in order, we don't need to do anything there. 5 and 4, they are out of order, and so we need to swap them and add 1 to the swap counter. And now we've moved 5, the next largest element, to the end of the unsorted portion, so we can now call that part of the sorted portion. Now, you're looking at the screen and probably can tell, as can I, that the array is sorted right now, but we can't prove that yet. We don't have a guarantee that it's sorted, but this is where the swap counter is going to come into play. So we've completed a pass. The swap counter is 2, so we're going to repeat this process again. Repeat until the swap counter is 0. Reset the swap counter to 0, so we'll reset it. Now look at each adjacent pair. That's in order, 1 and 2. 2 and 3 are in order. 3 and 4 are in order. So at this point, notice, we've completed looking at every adjacent pair, but the swap counter is still 0. If we don't have to switch any elements, then they must be in order by virtue of this process. And so, an efficiency of sorts that we computer scientists love is we can now declare the entire array must be sorted because we didn't have to swap any elements. That's pretty nice. So what's the worst case scenario with bubble sort? In the worst case, the array is in completely reverse order, and so we have to bubble each of the large elements all the way across the array, and we effectively also have to bubble all of the small elements back all the way across the array too. So each of the n elements has to move across all of the other n elements. So that's the worst case scenario. In the best case scenario, though, this is slightly different from selection sort. The array is already sorted when we go in. We don't have to make any swaps on the first pass. So we might have to look at fewer elements, right? We don't have to repeat this process a number of times over. So what does that mean? So what's the worst case scenario for bubble sort? And what's the best case scenario for bubble sort? Did you guess this? In the worst case, you have to iterate across all of the n elements n times. So the worst case is n squared. If the array is perfectly sorted, though, you only have to look at each of the elements once. And then if the swap counter is still 0, you can say this array is sorted. And so in the best case, this is actually better than selection sort. It's omega of n.
All right. Here is the bubble sort program. We have a main method. In our main method, we've declared an array of integers with these values 9, 2, 4, 1, 3. And then we're calling display method to print out the elements of the array before doing any calculation or any sorting. And then we call bubble sort method to sort all the values, and then again we display the elements. So here in line 12, as you see, we have the display method that is public static void. In this method, we have two parameters. The first one is the array, and the second one is a string when that we are passing through this before and after. So for the first time, it passes the array and before, and it shows the values, and then again it comes here, and we have a bubble sort public static void bubble sort method that has a parameter. It's an array, so it passes this array, and after sorting, again it calls display after, and it shows the values. So let's run the program with these values. All right. As you see, we have 9, 2, 4, 1, 3. And then after sorting, we have 1, 2, 3, 4, 9. So here is the program that we have. And then we want to see how it works. Let me show you how it works. All right. We have an array with 9, 2, 4, 1, and 3. This is the values, and the indexes starts from 0. So these are the indexes 0, 1, 2, 3, and 4. And then what it does, it calls bubble sort. So it comes here. In this bubble sort, n equals a length. So n equals the length of the array, that here n is 5. All right, and then I just pointed here. Then we have the F4. In this 4, I equals 0, I less than n minus 1. That n minus 1 would be 4. So the first, the loop here, the number of iteration is 5 times. So 0 through 4. The next one, j equals 0 until j is n 5 minus 1 minus I. So each time it changes. In each iteration, this is n 5 minus 1. It's 4. 4 minus 0. The first iteration is 4 minus 0. That is 4. The next time is 4 minus 3. That comes here. Then the next one, 4 minus this would be 2, and then that would be 3 here, and then 4 here, and then the last one. So how it deducts each part of that, each value. All right, so the first time j equals to 0, I equals to 0, also j equals to 0. Now in this inner loop, as you see, we have a decision statement that compares two values. So it compares a j plus 1, both of them were 0, so that would be, it compares a 0 plus 1 with a 0. Alright, so what it does, that would be a 1, a 0. A1 is 2. So if 2 is less than 9, so what it needs to do, if this statement is true, then swap aj with aj plus 1. So we have a temp, a container, a variable that, so we need to store somewhere. So we need to store these values somewhere. So we have a temp. Temp would be equal to a j. aj was here, as you see, this is a 0. So that would be 9. And then aj, that would be a 0. aj plus 1, the next one, that would be 2. And then aj plus 1, that is a 1, would be the value of 9. So a0 would be, okay. Now, as you see, we swap a0 and a1 here. So it swaps these two values. The next time that would be 2, 9, 4, 1, 3. This is the array that we have for the next iteration. So next time it compares this value with this value. Again, because this expression would be true, it swaps this one with this one. That's how bubble sort algorithm works. Let me clear this part and add some numbers here. And then you want to run the program. All right, this is the values that we have in our array, and then after sorting, you see that all these values are in order.